Okay, folks, so here we go.
Matt, I got a mocha one.
Excuse me. That means we need to quiet down and we need to pay attention here. We're going over ratios and proportions now, okay?
How do ratios have anything to do with geometry?
You'll see. So a ratio, okay, defining a ratio, it is very simply, it compares two measurements all right, or numbers. Okay, a ratio compares two measurements or numbers. Bless you. All right, the way you can see a ratio written. Sometimes a ratio is written as a fraction, like A over B. That's a ratio. Right? Also, that looks like a fraction, right? And ratios are like fractions.
Wait, do I get a book?
Have you gotten one yet? Then yes, grab a new book, please. You will need one. Oh, Haley, you too. You want to go?
Here, I'll give you one.
Listen up, please. All right, A over B. Or A colon B. This is another way to write a ratio. Or you can write a ratio using the phrase like A to B, like that.
Wait, I thought ratios were those two fractions.
These are all different ways to write a ratio. Okay? So, a proportion all right, so what is a proportion then? A proportion is an equation. And what makes something an equation? What does it have? What does an equation have? An equal sign, that's right. So an equation, it's just an equation that says two ratios are equal. All right, that is a proportion. All right, an equation that says two ratios are equal. So if A over B equals C over D, okay, if A over B equals C over D, so there's a proportion. Then, okay, so if A over B equals C over D, that's our proportion, then what do we know is true? We can cross multiply here. So we can say that A times D will equal what times what? B times C or C times B, whatever you want to say there. Yeah, very good. Good job. Okay? And that's cross multiplication. Yeah, I just wanted to formally kind of write that down.
When you say it like that,
okay.
oh, are you just saying cross multiply?
Yeah, it's just the cross multiplication there. If we have this is true, then we know that A times D will also equal B times C. That's like the cross, that's called sometimes, I'll put that word, cross multiplication.
Cross multiplication.
Because we're multiplying kind of across there. A times D, B times C. Okay? So now, why do we talk about ratios and proportions? How does it show up in geometry? Okay? So that's a great question Kyle asked. And it comes up in something called similar figures. Okay? Similar figures. Okay? And so what do we mean by similar? So when you say two things are similar, does that mean the same thing as saying they are the same?
No.
No, right. So what geometry concept do we have when we say two figures are the same? What's the geometry word for that?
Congruent.
Congruent. Similar, then, is not the same thing as congruent, but when two things are similar, they're kind of like each other, but they're not exactly the same. So similar figures are not necessarily congruent, okay? And so here's how we can tell if two figures are similar. Two figures, okay, are similar if corresponding angles are congruent. Remember that word corresponding is just like a fancy word for what? Corresponding is a fancy word for matching. That's right. It's a fancy word for just matching. Matching angles are congruent, and corresponding sides okay, are proportional. That means they are equal as like in a ratio. All right. You can see here, right? This is close to our definition for congruence. Congruence, we say two figures are congruent if corresponding angles are congruent, but also the corresponding sides must be congruent if we're talking about congruent figures. For similar figures, the corresponding angles are congruent, but corresponding sides have to be proportional. That means their sides can be written in two equal ratios. Okay? So as an example here, I'll show you kind of a picture. So let's say, for example, that I'm going to have a shape, and the first shape will be called MARK. And then we'll put a little squiggle. Notice there's no equal sign beneath the squiggle. The squiggle by itself means similar. Okay, that's the similarity. Okay, the squiggle by itself is the word, it means similar. So MARK is similar to LION. What's that? What's that? It is a person. So, let's see here. I don't want to draw this. Okay, there's that one. So, is it the same shape? You tell me. It should be the same. It should be like the same. I guess like the shape should be the same, but it should be different sizes. Exactly right. It should be different sizes. Yeah. Okay. So, just like a congruence statement, here, okay, we can use this similarity statement to find corresponding pieces. So, for example, angle M, according to my similarity statement, Derek. No talking right now. Ramel, shh, thank you. Angle M corresponds to what angle in my other shape? L. So that means because these two figures are similar, angle M is congruent to angle L. Notice I am writing the equal sign here because angle M and L are going to be congruent. In similar figures, their angles are congruent. I know I'm not being funny, so I know someone else is being funny. So that means someone's distracting you guys, so you need to stop. Yes?
Doesn't that say they're similar, though, not congruent?
Right, but what does it mean for two figures to be similar? Two figures are similar if corresponding angles are congruent. So angles will be congruent in similar figures. It's the sides, then, that will have different proportions. So, good question. So then angle A, what does that correspond to over here? I, very good. Okay, so I'll say angle A is congruent to angle I. All right, and then what does R correspond to? O, that's right. And again, it's easy to see. R is the third letter, O is the third letter, so those angles must be equal. Okay? And then last but not least, K, what's that got to correspond to? The N, right? And again, I'll do 4 arcs there. It's kind of getting a little ridiculous, but There it is. Okay. Guys, I think we need to put the jelly beans away, actually. Can we do that, Maddie, please? I think it's a little out of hand. All right. Snack time, we can take care of before class, but I think it's getting a little out of control here. You're all going to get sugared up. All right.
I'm tired.
Okay. Agreed. So, now, what else can we say here? Well, besides the angles being congruent, we can also match up, besides the angles being congruent, we can also match up corresponding sides. But MA is not going to be equal to LI. Okay, MA and LI are in the same position, but they're not going to be equal. They will be proportional. What does that mean? That means MA over LI, MA over LI will be the same ratio as AR over IO.
So why those?
So I'm not done yet. Will be in the same ratio as what other two pairs of sides? RK and ON. And there's one more here. We did AR and IO. We've got that right there. So again, I did MA over LI. I did AR over IO. I did RK over N. And then MK over LN. Exactly right. Okay. Notice with this first ratio that I did, I started with the smaller shape and put it over top of the larger shape. And then since I did it that way for the first ratio, all the other ratios, I had to take the smaller side over the larger side, the smaller side over the larger side, smaller side over the larger side. Okay? But these corresponding parts will always be similar. We have to be very careful that we're always comparing corresponding parts. So for example, MA has to go over the full side here, LI. AR, this full side, has to go over the full side, IO. RK, the full side, has to go over the full side, ON. And then MK has to go over LN. Okay? Well, so we don't know necessarily, we haven't talked about like necessarily transformations just yet. So here, it doesn't matter which order you put it in. You could say LN over MK, and then you have to say equals IL, for example, over AM or something like that. So whatever direction you use. Exactly. Keep it, maintain that. Exactly right. Okay, so that's that. Questions on, any other questions on that? We're actually going to get into like math now, okay? Like, well, this is math, but, some like numbers and stuff, okay? So, if you would please then get your books out, and we're going to look at page 601. 601. is we're going to look at there. So if you want to get your pages out, 601.
It's more than that. It's like 1,000.
Okay.
Yeah. It goes to 2,000.
It does, but we're going to skip ahead of a few things to get into this part. Okay, 601. Okay. So we all there? And if you guys would like, we're going to be measuring some angles here. If you want to measure along with me, you can go up and grab a protractor, or if you just trust my measurements, you can do that too, okay? So I will leave that up to you whether you want to measure yourself or if you want to just follow along with me on the measurements. All right? So, 601.
601.
So looking at this, the title of the section here is Corresponding Parts of Similar Figures. So if we know two figures are similar, what can you determine about measures of corresponding angles and lengths? That's what we want to try and figure out here. Okay? So looking through 601. So looking through here, we're going to connect angles and sides of figures. So we know that if figures are similar, the side lengths are proportional and the angle measures are equal, right, as we just talked about. If you have two figures with proportional side lengths and congruent angles, can you conclude that they are similar? So let's take a look here. So, consider the graph here of ABCD, and then we also have KLMN. Are corresponding angles congruent, yes or no? That's our first question to figure out. Does it look like the corresponding angles are congruent? It does, right? But let's actually go through and do some measurements here. So for example, angle A here, Dominic, what does it look like angle A's measure is going to be right there? Can you see that okay? What does that look like the angle measure will be there, Dominic? For angle A right here. This one you can probably eyeball without even having to measure it. The angle, so you see this shape right here? and here's angle A right here. What do you think this angle is right there? What measure is that, you think? Yeah, so what degree measure would that be? Yeah, 9 degrees. Okay, and then looking at angle B, okay, this one we're going to have to actually measure, right, because I don't have enough, it's not quite there. So let's see, if I measure that, it looks like it's going to be, I'm going to go ahead and call that 60 degrees for angle B. Okay, you guys kind of see there when I put it on there, it does kind of line up with that line for the 60-degree angle. Okay, angle C, that's another one. Let's see here, I have to measure that. I'm going to put it upside down to measure it this way, and that looks like that's going to be 120.
Can you like tell us like how you're doing that? 'Cause I can't figure that out.
Okay, you forgot how to use the protractor? Okay, so...
I just forget how to use the protractor.
Oh, okay, well, because that's what we're just using, the protractor here.
I know, but like maybe it sounds dumb.
Well, I'm sorry, I didn't mean to sound make you sound dumb. I was just like, if you forgot, that's just, okay, because I figured we had done it, so, but here we go. So, this is the angle, starts on this side, so we start with these numbers because it starts at 0 there. And then this angle opens up to the 60, right there, you can see there's the side, it goes out to the 60.
Yeah, but it doesn't, it goes up, when it's 60, it's like 65. Yeah, that's where mine goes. Mine's not on a line.
I see what you're saying.
Oh, I see, it's 60, yeah.
Okay, it's again, this is like, we're, because it's kind of hard to measure. Sometimes these aren't drawn that well, too, so, but we'll say it's 60. And then next, the other one, 120. And then angle D, very clearly, is also 90 degrees. Okay? And then we'll do the same thing here for the big shape. So for the big shape, let's see here. So Xander, angle K, what do you say that measure is going to be? 90. Yeah, 90 degrees. Right? Angle L, I'm going to actually, Kyle said it's all going to be the same, but let's just take a look to see. Make sure we convince ourselves we're right here. So, maybe I didn't do a great job with that, because you're right. I think, you know what, you might be more right there, okay, but it might be 65. But it should be the same, either way. It's going to be the same. I probably just didn't measure this one well enough, because I didn't draw I should have drawn the line longer. Okay. All right, Ramel, can you come over here, please, and sit right there? This one of these empty seats right in front of Jason and Ryan. Thank you. Okay. So we'll go ahead and say it's 60, though. Okay. And then angle M, again, if we measure it, it's probably not going to be exactly 120 because I kind of messed up the other measure, though. But yeah, we'll say it's about 120. Okay. And then angle N is definitely 90 degrees.
That's right.
601. Yes, one of those two, please. And please make sure you follow along now. No more goofiness. All right. So we can see that the angles are equal. Angles are congruent here. All right. Now, let's also then, for letter B, it says, are the ratios of corresponding side lengths equal, yes or no? So let's see here. AB, what's the length of AB?
Looks like 1, 2.
So yeah, 1. Oh, and be careful here. What are these? Each box is actually how long? It's 2. So you gotta be careful. So that's 2. So for A to B, it's 2, 4, 6, and we could say that's like 1 more, so 7 length. All right. KL is right here. So we'll again say 2, 4, 6, 8, 10, 12, 14.
That's 1/2.
Okay. And it's 1/2 if you simplify it. Okay. All right, let's try a different set of sides here. So let's see here, BC to LM. Well, that's a little bit harder to measure because it's got that diagonal length there. So we'll hold off on that one. But let's see. Oh, we can do MN and CD, no problem. So let's go ahead and do those. So CD is how long? 4. It's 2 boxes, so it's 4. And then MN is 8. Very good. Which simplifies to what? 1/2. Yeah, okay, interesting. Same ratio. And then AD is, how long is that? It's 6. And then KN is
3.
2, 4, 6, 8, 10, 12.
7.
So it simplifies to
1/2.
1/2.
They're all going to simplify to 1/2.
That's what, so here, that's the question we're being asked, right? Are the ratios of the corresponding side lengths equal? And are they?
Yes.
Yes, they are all equal.
You say yes when you haven't even figured out BC over LM.
Well, I haven't done BC and LM because we don't have that, we can't, to do that measurement, we would need to use like the distance formula, and I didn't feel like going through and doing the distance formula there.
Why would you multiply by 2? Or why would you count by 2 then?
Oh, because if you look at the scale in the picture here, Jaden, for example, this second block, this one right here, is 4 away. So that means each block is then 2 individually. You see what I'm saying? Like these, we're not counting by ones with these blocks. Each block is 2. Okay.
Would you do that on everything?
Well, it's just whenever you have to look at your scale. Whenever you're graphing, you gotta check the scale. That's all. But in this case, when I see the blank then 4, that means it's counting by 2. So yes, you can.
So if I'm doing a problem on a worksheet,
Yes.
and I do like letter B, like what we just did,
Right.
but how am I supposed to answer yes or no if I haven't found out one of the sides? Because maybe they made it purposely difficult to find it because it makes no. Like,
I see what you're saying.
you're kind of just guessing.
I see what you're saying. Oh my goodness, that's really bad. Okay. Let me do it this way then. We can
Like, you know what I mean? Like,
I know what you mean.
It's kind of blind for people to say, oh, yes, yeah. when
I
they
understand.
don't really know.
Nope, you're right. If you measure, okay, so you can see here that this is roughly like 1.5 centimeters, right? You see that? Okay, and then we can do the same thing here, and you can see that it's roughly 3 centimeters as well. Again, it's a little bit less than 1.5 if I measure here correctly, right? It's just under 1.5. Can you see that?
Yes.
And then, so that means if I to double that, right, because that's what this is double, that's just under then 3 centimeters. So you can see that it is true there for that. Now,
1 over 3?
no, so it was 1.5, remember, over 3, which then gives us the 1/2 when you simplify it. Okay. But then that was using, what was that, centimeters. So I should say like 1.5 centimeters over 3 centimeters. Okay, gives you the 1/2 there. All right. So that's the idea. So then, are these two figures similar? Yes. Corresponding angles are congruent.
Yes,
I'm going to use the symbol for congruent. Corresponding angles are congruent.
they're not the same size.
And
Congruent.
hold on a second.
Similar.
Similar.
And corresponding sides are proportional. That means they have the same ratio. Ratios are equal. Okay? That's how you can show that two figures are similar. Corresponding angles are congruent, corresponding sides are proportional. Okay? So that's the idea there. Questions on any of that? Alright, let's turn the page then. Oh, sorry. Went too fast. Yeah.
Are we going to have like a problem like BC over LM on like a test or anything?
We will talk more about that later. Right now, let's say no, because you're right. It wouldn't be fair to give you a problem that would require you to actually measure that without a ruler or something right now. But we'll see about that later. Right now, don't worry about it. No. Right now, as of what I've taught you guys, no, I wouldn't expect you to do something like that. Okay. Next, let's flip it over here. Okay, so. Nah, probably not. Shh. All right. So let's look here at letter D. Okay, letter D says consider the graph of ABCD and EFGH. Are corresponding angles congruent? Yes or no? And I'm going to pick somebody here. So let's go to. So Derek, if you look at this shape right here, ABCD, and you look at EFGH, are corresponding angles congruent? Does it look like, for example, A here, Derek, what would that match up with in the bigger shape? What is it? Right, and do they look like they're the same angle?
Yeah.
Yeah. How about B and F? How about B and F?
B and F, yes.
Yep, and C and G?
B and G.
And D and H.
Oh, yep.
Okay. So, can we say then the corresponding angles are congruent?
Eduardo says yes.
Eduardo says yes, and Eduardo is right. So corresponding angles,
I should write
Wait, do
Walter
we have to
says
write
yes.
that corresponding angles?
you can just write yes if you want to.
Alright, good. 'Cause I'm not.
Yes.
No, but like on the test, when we get in trouble if we don't.
We get in trouble.
In trouble, you mean when you get a bad grade?
I mean, points taken off, guys.
So I'm going to say corresponding angles are congruent because all angles are 90 degrees. Okay.
It's not a big point, actually.
It's very easy, right. So Jason, to answer your second question, yes, you can potentially lose points. In fact, anytime it says to explain, that means there's points attached to it. Okay, so you want to make sure you do the explanation. So it's important to understand the why, Jason. It's important to understand the why as well.
If they weren't all like specific, like, you know, like, see it, like,
Right.
the measure.
You would need to then use like a protractor or something.
Can you hold on? Jaden and like, can y'all shut up?
All right. Back on track here, guys. So, letter E. Yeah. Are the ratios of corresponding side lengths equal? Okay, yes or no? So let's take a look here. So AB, okay? How long is AB? Again, check your scale. How long is each box here?
8.
Oh, each box is, well, AB is 8, but the length of each box is 2, so that's right. So AB then would be a unit length of 8, right? EF, okay, has a length of 14. Each box is 2. There's 7 lengths there, so it's 14. Okay, right? 1, 2, 3, 4, 5, 6, 7. Yeah, 14. Okay. All right. BC has a length of 3, so that's a 6. And then FG has a length 10. All right. And then CD has a length of 8 as well. GH has a length of 14. All right. Derek?
Yeah.
Cut it out. I don't know what you need to ask for anything right now. We're taking notes, so just pay attention.
10.
All right?
They're right there.
And then AD is
6,
6 and then 10. Now,
Magical, yeah.
are the ratios of corresponding side lengths equal? Well, definitely these two are equal. Definitely these two are equal because they're the exact same numbers. But are these two equal?
No.
Well, we don't know yet. We can simplify both of them. So let's simplify here. 8 divided by 2, right? We can divide that one by 2 is 4, and that becomes 7, okay. What about 6/10?
That would be 3.
3 and 5. And those don't simplify anymore. So can these fractions be equal?
No, sir.
Yeah, no. So the figures are not similar. What do you need? Bathroom?
Yes, please.
All right. The figures are not similar because the ratios of corresponding sides are not equal. Okay? The ratios of corresponding sides are not equal. So the angles are equal, that's great. But the sides, they do not have the corresponding ratio measures, and so that does not make them... Sorry, it's just it's a scribble out. The figures are not similar because the ratios of the corresponding sides are not equal. All right? And if only one ratio is not equal to the other three, then the whole thing is not similar.
You probably already.
If only one pair of corresponding angles are not congruent, the whole thing is not similar. It only takes one thing to fail for the whole thing to not be similar. So, sorry, Kyle?
I think you can already call the next one.
So Kyle says he thinks you can already call the next one. So what do you say there, Kyle? Just by looking at it, Kyle.
There is no way similar.
There are no ways similar. Why? What's giving that away to you?
First of all, it's like the angles are like way different.
So boom, right there, done. That's all you need to say. The angles are in no way in similar relationship right here, right? If we were to measure, for example, angle Y, there's no way it's going to be the same angle there as angle R, okay? And so, I'm sorry?
Do we leave at regular time?
Regular time, that's right. So are the figures, so I'm going to go ahead and just skip down. I'm not even going to bother doing any of these measurements. If you guys want to do the measurements, you can, but you can just kind of look at it right there and just see. Angle Y, which would correspond to the angle R there's no way they're going to be the same. And so are the figures similar? No. Corresponding angles.
Well, how do you know about the size?
Does it matter, though?
I mean, yeah, because it's two different things, angles and size.
Right, but what does it take for two shapes to be congruent? What does it take for two shapes to be similar? The corresponding angles must be congruent and the sides must be proportional. If one of those two things fail, they're not similar. So without even having to measure the sides, you can see that angle Y and angle R, if we were to actually measure the angles, would not be the same.
So they have to be like, it's not like a dilation, because the one up above is a dilation.
It's a dilation, but the dilation's uneven. You understand what I'm saying? Like this BC only dilated by a different amount than the AB did to the EF. You see?
So they have to be the same shape for them to work.
Yes, almost like just imagine it like blown up or shrunken down. So still like the same form almost, we'll say, but just different sizes. Okay, does that kind of make sense, Ikeva?
Yeah, but like, what if they will they ask us like to find the angles and stuff like that? Is this a no?
Potentially, yes. But again, it's just a matter of just use your protractor to measure angle R, measure angle Y, and then once you've shown that those two are not equal, the whole thing is not similar. You just need to show one thing's not equal there.
And like when you measure angle R,
Yes.
like how do you know whether to put your protractor up or down?
So it's just a matter of lining it up here. So for example, and do you mind if I pick a different angle? Let me pick like angle P, for example, or would you want me to stick with angle R?
It doesn't matter.
Okay.
I have trouble measuring it.
So first of all, angle R I can see is just way too small for us right now. So what I would say is extend the sides using a pencil, and then you just place your protractor on the angle.
So we're doing P, right?
Oh, sure. If you want to do P, yep. Yeah, I know that's what I said. So yeah. So there it is. Just line it up, and then just use the pencil markings there to kind of see wherever that ends up on your protractor.
So it's 10 degrees.
And it should be a little bit more than 10 here. Let me just go ahead and do it since I'm here. All right, and then Jaden, I see your hand. What's your question, Jaden?
Is there any way to write corresponding angles, like, and then it's too much to write?
It's too much to write. I know, it's math class, and you guys don't want to write. Unfortunately, no, Jaden, there is no shortcut for that. You'll just have to write the word out. Corresponding.
So it's like...
Okay, and then if if you're concerned about spelling and stuff like that, don't worry too much about that. I will, hopefully be able to read that, okay. So it looks like, to me, it looks about 30, probably just under 30 maybe like 20... I don't know, 27, 28, something like that. So I'm not sure.
Directly on the line.
Interesting. Well, here's mine. You can see it right there.
Yeah,
I extended it.
I have mine just the way you have it, and I have it going across the 50 line.
Let me see.
All right. Well, I'll come take a look at it in a little bit here, but there's that. Okay.
It's just looking there, bro. You're supposed to go up.
I know, I have it up.
All right. Oh, Jason, I'll take care of it. Jason, thank you. I'll take care of it. Okay, I'll come see you later. I appreciate it. I will come and help later. Okay. We'll take a look at that later. But because we're gonna move on here. All right. Next thing I want to talk about then is this. Okay. So page 603 now, please. All right. 603. So. Once we've justified, so we're going to be justifying properties of similar figures using the transformations and stuff like that. So we basically got this property right here. So we already know this, right? Corresponding angles of similar figures are congruent. Corresponding sides of similar figures are proportional. So if we say here triangle ABC is similar to triangle XYZ, then A and X will be congruent. B and Y will be congruent. C and Z will be congruent, right? We saw that already. And also, if you look here, the similarity statements also give us the ratios. AB, look at that, there's AB, the first two letters, over XY, have to be the same proportion as BC over the YZ, have to be the same proportion as AC over the XZ. You see that? It's the matching kind of points there. Okay, the matching kind of points there. All right, so if we scoot down here a little bit to look at the bottom of 603 there. All right. We can see that here, for example, we're told to identify properties of similar figures. So, for example, it says figure EFGH maps to figure RSTU by a similarity transformation. write a proportion that contains EF and RU. Okay? So Kyle, pay attention please. Stop talking to Evan. So why don't you like turn your body so that way you're not tempted to talk to him. Thank you. All right? So write a proportion that contains EF and RU. List any angles that must be congruent to angle G or angle U. So we have two things we've got to do here. First, write a proportion that contains EF and RU. Well, here in this, there's EF. According to this similarity, then, if these two things are similar, what does EF correspond to over here? RS. We write EF over RS there. See that? Okay. And then we also want to use RU. Well, RU's over here, so that's got to go in the denominator of this one. And RU corresponds to, what you can see here, EH, right? So it's EF over RS equals EH over RU. Notice that this shape's on the bottom here, so that means this shape, those corresponding parts will be on top. Okay? All right. And then lastly here we also have the angles. So it says, list any angles that must be congruent to angle G. Well, here's angle G. That's the third letter, and so it's congruent to T. Okay? And then U is the fourth letter here, so it corresponds to H. And so they're congruent and they're congruent. All right, so let's actually do that one here for letter B. Okay, it's this figure JKLMN maps the figure TUVWX by similarity transformation. Write a proportion that contains TX and LM. List any angles that must be congruent to angle V or congruent to angle K. So you'll see here they want to have TX. So TX they put on the bottom because it's like the second shape. So there's that. So TX. So according to this then, what does TX have to match up with here, Billy? So here's TX, Billy, right there. What does that mean it matches up to over here? JN, you got it. That's right, JN. Okay, very good. And then let's see here. For this next one here, LM, so there's LM. It's those two letters. What does that have to match up with? Let's go to Zaria. What does LM match up to over here? VW, that's right, like Volkswagen. Okay, VW. All right, so those two match up. Notice again, JN is from the first shape, it's on top. TX is from the second shape, so it goes on the bottom, corresponding, right? Equals LM from the first shape on top, VW from the second shape on the bottom, okay? Next, blank is congruent to angle V. Let's go to someone's here, that'll be helpful. Oh, not here, let's go to Jason. What corresponds to angle V? So here's angle V in this shape. What does that mean it corresponds to over here?
Wait, angle V?
So angle V corresponds to what over here?
Angle L.
Very good, sir. Angle L. And you go ahead and do the second one there too. Blank is congruent to angle K.
K will be U.
Very good. Excellent work. Okay? Just from that similarity statement. Good job, Jason. Okay? Questions on that? Pretty straightforward, just like using congruence. The proportions are a little bit funky. Just remember, again, they did the first one over the second one. So first over second equals first over second from the shape there. All right. So we'll skip number 4, and we'll skip number 5. But let's do number 6 here real quick, because this is pretty good. So it's an error analysis. So there's an error here. Okay. So number 6 says triangle DEF and triangle UVW are similar. So these two are similar. They wrote here, or they're asking, is DE over UV equal to VW over EF? So is there an error in this statement? Is DE over UV equal to VW over EF?
Yeah.
Okay, so those parts do match, right? DE and UV, so DE from the first triangle over UV from the second triangle. Should that equal VW from the second triangle over EF from the first triangle? Right. So the letters are correct, like VW and EF do match up, but these need to flip. So it should be DE over UV equals EF on top over VW. Good catch there, sorry. Yes?
When you're writing those, the fraction equals the other fraction.
Yes.
Whatever comes from DEF, the first triangle, has to always either be on the top or the bottom.
So, yeah, you can pick whichever one's on top, whichever one's on the bottom. But once you establish that, it's got to be that same for all the other relationships. Yep. Okay. I was using these. They're very ugly there. Sorry about that, but that's the idea. Okay, so now let's see that with some actual, algebra thrown in. I know you guys have been waiting for algebra, right? There it is.
I never got the answer.
Oh, I'm sorry. It should be DE over UV, so that stays the same, but then it equals, you flip them, EF over the VW. That's all. Okay? All right, so finish up here. So, applying properties of similar figures. So the properties of similar figures can be used to find the measures of corresponding parts. So, given that the figures are similar, so these two are similar, these two are similar, find the values of x and y. All right, so letter A says find the value of x. All right, so if you look here in these pictures, where is x in this picture? Well, here's C. It's got an angle C. It's got 4x plus 27 degrees. What does it look like C in this shape corresponds to in this shape? R, that's right. So how should these two things be related? They're going to be equal because corresponding angles are equal. So 4x plus 27 equals 95. Solve for the x, you get x is 17. So there it is. Okay, you've solved it. X 17. Now, to find the value of y, you'll notice here that y shows up in the sides. 3y minus 5, what does that correspond to over here?
Yeah, but there's another y.
Right, we'll get to that. What does the 3y minus 5 correspond to over here?
5.
The 5. So you can write 3y minus 5 over 5. That's one of the ratios, but then we need another ratio, and so, okay, what's the other ratio?
4y.
4y over the 10, not equals over the 10.
Alright, but it's okay if you do 3y minus 5 over 5 equals 4y over 10.
Yeah, exactly.
Okay.
The other way around, yeah.
So how would you solve something?
So, well, what do we do when we have a ratio over here and a ratio over here? We cross multiply, right? And so you can do the 5 times the 4y. I'm going to kind of like, they basically do that there. I'm going to do it here, though, too. So the 5 times the 4y gives us 20y. Okay? And then 10 times 3y minus 5. What does this 10 multiply to over here? When 5 times the 4y. I cross multiplied there. 5 times the 4y. What does the 10 multiply to over here?
5.
The 5 and the 3y. So it's 10 times 3y and 10 times the minus 5 there. So it becomes 30y minus 50. Okay, the 10 distributes to both terms.
Could you do plus negative 50 too?
Yep, if you want to make it plus negative 50, yep. All right, and then we solve, okay? So, to solve this equation, the first step, Ramel, is going to be what? To solve this equation here, what's going to be our first step?
We're going to subtract 20y.
Okay, subtract 20y from each side. We can do that. Whoops, I'm putting equals there. Very good. What's going to be left over here, Ramel, when we subtract 20y from 20y? 0. Very good. And that equals, let's see, 30 minus 20 is 10y minus 50. Thank you. Add 50 and then divide by 10. Very good. So plus 50. I'm going to run out of space here. Plus 50. So you get 50 equals 10y. Then divide both sides by 10. You get y equals 5.
Can you like put on one?
Yep. Okay. Just solving the equation there. That's all. Are you good?
Wouldn't you like put it in for something else?
So in this case, all the directions said were to find the value of y or find the value of x. So actually we're done. We've answered what the directions asked. If we wanted to get the actual side length for A, B, then yeah, we plug the 5 back in. But all I asked for was y or x here, for whatever reason. Okay? So that's it.
Mr. Wiz,
Yes.
class is gonna end soon.
Yes.
Will you just like, I have my protractor, but like.
All right, I'll get you in just a second. Let me get the assignment, and I'll get you going on that. So your assignment for tonight and for the weekend. Okay.
Joe,
I would like you to. So here it is, page 606. Page 606. I would like you to try 1, 2, 3, and 4.
Wait, is this homework?
Yes, this is homework.
Oh man, what page is
5 and 6, so 1 through 6 there,
Homework on homecoming weekend.
because
Yeah,
you have time to do homework on homecoming
I
weekend.
have to do my feet. I have to clean my feet. I have to.
That is that your annual feet cleaning? All right, so page 606, 1 through 6, and also page 607. 607, 1 second, hang on please. 607, 15 and 16 AB there, okay? So, I'll write on the board.
Can I use your pen real quick? I accidentally put my pencil on.